Again, good morning to all of you. Welcome back to the course on artificial intelligence and soft computing. During our previous session, we discussed about different uninformed searching techniques like depth first search, breadth first search, and then uniform cross search, right? And also we discussed about know what are the different the parameters through which we are going to decide whether that searching technique is the best one. So the performance of the searching algorithm, which was determined based on the completeness, time complexity, and then space complexity, whether that searching technique is providing an optimal solution or not. Based on that, no, we identified different, no, different the cost, time complexity as well as space complexity with respect to the different searching techniques. In today's session, we'll start with the another uninformed search technique, which is a depth limiter search. When you talk about the depth limiter search, so it is very similar to that the depth first search. But when you talk about the depth first search, say imagine that we discussed about one drawback or a disadvantage of the depth first search is that in case if the depth is infinite, so how the depth first search algorithm will works. So for example, if there is a tree and the depth first search, it will take a first child of a tree, and then that first child will be expanded and its own child will be expanded. So this process will be repeated unless until it reaches the leaf node. That means that the one subtree will be taken and it further leftmost child will be expanded. So this process will continue till it reaches the end or the leaf node. So this will cause a problem with the infinite solution or infinite node. In that cases, suppose if the depth is infinite limit, in that cases, no, it will not be an optimal solution to provide to find the searching element in the tree. So to avoid that, so now we are going with the depth limiter search. When you talk about the depth limiter search, right, in that, so we are going to fix a specific limit. So now what we are going to do is that, so instead of searching an element in a specific child or in the specific subtree to the iterative depth, so we are going to restrict with the specific depth limit. For example, when we talk about the depth, say for example, maybe the depth level 2 or the depth level 3, and so we are going to have a deterministic depth. So within this depth only, the searching process will take place. So this technique will automatically avoid infinite looping state. So this is what the problem, or this is what the intention behind the depth limited search. So to avoid the infinite loop or infinite searching technique in the depth first search, no, we are implementing a limit with the depth. Now, what kind of failure which happens in the depth limiter search? The first thing is that it's very similar to the all other searching techniques. The standard failure value, which indicates the no solution. Suppose if there is a restriction with the limit, if there are only the level two is searching process. Suppose whatever the node which you are searching, if that node which is not present within the level two, automatically this algorithm which is going to declared is a failure one, because the node which we are trying to select that may lie in the level 5 or level 6 or more than that, but we restricted with the level is 2, right? So in that cases, so this the depth limit search will not provide a solution. The second thing is that if the cutoff value indicates a no solution within the depth limit, very similar to that, right? Suppose, what we can do is that within the limit, if you are not able to find a solution automatically, so this the depth for search algorithm or the depth limit search algorithm, which will becomes a failure one. So I'll try to explain with the diagram so that you will understand it more clearly. So now this is what the tree which is given, which is displayed in front of you. The root node is A. Wait a second, I'll take a highlighter. Right now, so A is the root node and it has four children, B, C, D, E, and again B has a two children, which is F and G, and C as a children, a child as H, and D as a children, I and J. So by this you can identify that the root node and with their respective childrens. Now what I'm going to do is that, so here the depth limit search, so here I'm going to consider that suppose if the depth limit is equal to 0, in that cases what will happen, only the root node which is going to be expanded. So now this is the example for the limit 0, whatever the diagram which you says, right? The node which we expanded, which is highlighted in the red. So that means that in the level 0, the root node A only has expanded. When it comes to the level B, sorry, level 1, again, the respective nodes, the root node A's children B, C, D, E will be expanded. B will be visited and then it travels back to A, and then C will be visited and then it travels back to A. So whenever it visiting, it is going to do the comparison whether that whatever the node which you are visiting, whether is it a goal node. If it is a goal node, the algorithm will terminate. Otherwise, it may move further, maybe backwards or maybe forward, right? So first it will from A, it will go to B, and then if it is not a goal node, again it travels back to A, and then it will traverse to the C. C will be visited, and it is going to be compared whether it is a goal node. If it is not, again it travels back to A, and then D will be visited, and then E will be visited. Suppose if my limit is equal to 1, the same scenario, if my limit is equal to 2, in that cases B will be expanded. Very similar to that, the process will be repeated, right? So here I am going to use the depth first technique with a limit, with the definite limit, right? So here I am going to consider my limit value is equal to 2. So first root node A will be expanded and its first left child, which is B. So that is going to be expanded. And then further B's children, which is F and G, are to be expanded. F to be expanded, and it is going to be compared whether it is a goal node. Else again it travels back to the root node B, and then it will traverse to the right subtree of B, which is G. So now this is going to be visited, and that is going to compare whether that is the goal node or not. If it is not a goal node, again it travels back to B. One thing I wanted to quickly inform you that, so according to this diagram, my goal node will be O. Is it clear for all of you? My start node is A, and then goal node is O, right? Sorry, I forgot to inform at the beginning. For the given tree, I need to search. My goal node is O, right? I wanted to find whether within the specific limit, in the depth limit 2, whether this goal node is present or not. So I was explaining, if I restrict with my limit equal to 2, in that cases, root A will be expanded and its first left child, B, will be expanded and its children, F and G, will be visited further. And so these two are not the goal nodes. So automatically it travels back to the root node A, and then C will be visited. Now C as a child H, the H will be visited because I restricted with my limit is equal to 2. So so until the limit 2, the nodes are which present. So that is going to be visited based on the depth first search. Basically, it's a depth first search, but the searching process which we are restricting with the specific limit what we mentioned. And then the the H node will be visited, and it is going to be compared whether it is a goal node or not. If it is not a goal node, again it will traverse back to the A, and then it will move to the next child, which is D, and again its children are to be visited, I and J, and then again it travels back to A, and then after that the node E will be visited. So with this, so we come to the conclusion, we visited all the nodes, all the root nodes and its children, which is present in the level 2. Right after visiting node E, so this algorithm will gives or will informs as a failure, because whatever the node which we wanted to visit, that is not lies within the limit which is we are restricted. What was the goal node which we wanted to visit? What is the goal node we wanted to visit? Quickly write in a chat box. Anyone? Yes. Thank you, Bharat. The node O. Okay, okay. Thank you, all of you, Danish and Nauzin. Right. So the node which we wanted to visit, which is not present within this limit 2, in that cases, it is going to be declared as a failure. Suppose if we increase our level 3, even in that case also, we will not be able to find, because again, so this will be visited, and then F doesn't have any child. Again, G will be expanded, K and L, and then it will terminate here, and then it move back to the root node. And then so here H also does not have any child. Again, D will be expanded, I, and then M will be visited, and then N will be visited. Even if we limit with L is equal to 3, in that case also, this algorithm will not provide a solution. Or again, in that case also, it is going to provide only the failure. So by the way, so it depends upon the predetermined limit, right? So we may not sure that at what level my the goal node present, right? Every time it is very difficult to change the depth value. So a depth value which might be fixed in one specific value, maybe 4 or 5, right? Based on that, if the searching node or goal node is present within the limit, and so that algorithm which is going to provide a solution. Otherwise, it is going to declare it is going to provide a failure solutions. Now, what is the problem with the first technique is that every time we need to keep on changing the limit. That cases, what we do is that the alternate technique with the existing depth limit search. So here I repeat. So with this algorithm, which I consider my limit value is equal to 2, as per my limit value, though the goal node is present somewhere in the bottom, but this algorithm which given the failure state because the limit which I restricted with 2, right, within the limit 2, so my goal node is not present. In that case, is this algorithm which provides a failure solution. So to alternate with this technique is the iterative deepening search. This is almost similar with the depth first search as well as the depth limiter search, right? Now, how this iterative deepening search, which is going to differ from the previous search, means so the limit which will be iteratively increased one at a time, right? First, it will check for level 0, and if the level 0 node is not a goal node, and it will increase its level. So level 0 to level 1. All the nodes which lies in the level 1, that nodes will be visited. Again, if the nodes are not present in the level 1, the level value will increase to level 2, right? Again, the nodes which are present in the level 2 that are going to be visited, and if it found a goal state, the algorithm will terminate. Otherwise, the level value will increase from 2 to 3 and then 3 to 4. So this process will go on and on unless until it finds a goal node. Is it clear for all of you? So the depth first algorithm, right, which is the combination of the depth first search, sorry, the iterative deepening search, which is the combination of depth first as well as the breadth first algorithm. And when you talk about the memory requirement, which is very similar to that, the depth first search, which is the order of B and D. What is B? B is the branching factor, and D is the depth, right? Again, when we talk about the complete, so this it very similar to the breadth first search. It is complete when branching factor is finite. Now, so I was talking about the breadth first search, right? When we talk about, suppose if the branching factor is 10, suppose the root node has a 10 children, again, every node in the tree which has a 10 children. So you may know we discussed about one a chart, so it may takes near about 30 days or some, no, it requires 30 days to visit if a node the level is 10. Very similar to that, the memory which is required to store all the elements, all the state spaces, which becomes around a terabyte memory spaces. Very similar to that. It depends upon this iterative deepening search, which is going to be completely depends on the branching factors. If the branching factor is restricted or limited, so here this algorithm also will try to provide an optimal solution with the restricted time limit. Now, when we talk about the iterative deepening search, other some of the other factors, right? It may seems to be the wasteful because so it generates some multiple times. So every time when we increase the limit, again the searching process will have to start from the root node, right? So again, otherwise also the whatever the node which are already visited that are going to be stored in the memory for the reference. So based on that, it is going to keep on compare, and then the process will be repeated. So every time it increases the level value, right, automatically the searching process may be initiated from the beginning or from the previous data or the node which are visited, so that are going to be stored in the somewhere from that location or memories. and the data will be referred, and the further process will be repeated. Now, so this is a diagram through which you will quickly understand, or you will understand more clearly how the iterative deepening searching algorithm which works. So here I restricted, initially I start with the limit 0, the node A, that is the root node that is going to be visited. And when it comes to limit 1, root node has two children, which is B and C. B will be visited first, and then it travels back. C will be visited second. So if the goal node is not found in the limit 1, and then it will move to the limit 2. In that cases, again, root node A will be expanded first, and then B will be visited, and then the left side, the left child trees, right, which is D and E will be visited. So here again, so this is going to work based on the depth first algorithm only, depth first search technique only, right? So here D and E will be visited, and then it travels back to the A, and then C will be visited, and then F and G will be visited. So this is what how the level 2 iterative deepening searching algorithm which works. Suppose even in this level also, if the goal node is not found, again further it will be expanded to the level 3, right? Again, so this process will continue like a depth first search. Root node A will be visited, and B will be visited, and then D, and then D's children's, right? H and I will be visited, and then it travels back to the D, and then it travels back to B. B's right child E will be visited, and then J will be visited, K will be visited. If the goal nodes are not found in this subtree, and then it will traverse back to A, and then from A it visits C, and then C's left child, which is F, will be visited, and then L will be visited, M will be visited. Again, when the C's left subtree, if the goal node is not present, again it travels back to its root C, and C subtree or right subtree, which is G, will be visited, and then N, and then O will be visited. By the way, so this process will continue unless until it finds a goal node, right? Now, is it clear for all of you how this iterative deepening search algorithm works? Any clarification required or any doubts based on the depth limit search as well as iterative deepening search? If you have any doubts, you can quickly write in a chat box. So I'm happy to clarify your doubts. No, it's not like a BFS, it's DFS. It's the combination of depth first search and then breadth first search. So how, Mohammad Danish, can you just know, this is not based on the BFS. When we talk about the BFS, suppose if I'm visiting a, right, the level 1 node will be completed first. So A will be visited, root node A will be visited, and A children B and C will be visited first. When we talk about the depth breadth first search, when you talk about the depth first search, whatever the limit which you are giving, first it is going to visit in the depth, and then once if all the nodes in the specific depth are visited, then only it move to the right subtree. Is it clear?